Apart from the series and parallel connection of the blocks, we have another form in which the blocks could be connected to each other, and it is called the feedback. The general concept here is that the output of one block, which is G of S here, the output signal that we get from it is C of S, is fed back usually through another block to its input. So that's why the system is called the feedback system. You can see examples here. So in the first one that is shown here, we have a summing point. That summing point's output, E of S, is used as the input to the controller, and then the output of the controller is used as the input to the plant. Basically, this is a control system. And then here we have the output signal C of S. But then this signal is fed back through this loop. So it goes and it arrives at the input of the summing point. And we know that the output of the summing point will be used as the input of the system. So we will have a loop over here. In a simplified example here, we have only two blocks, G of S and H of S. G of S is in the feed forward pass and H of S is in the feedback pass. And we have the summing point here. And the idea over here is indeed to combine these two with each other and end up with a single block. That single block, which is shown here, will have a transfer function, and we can determine the transfer function based on the transfer functions of G of S and H of S. You can see how it is obtained. T of S, we call it, the transfer function, could be obtained as G, the transfer function that we see in the, let's say, forward pass, divided by 1 plus minus G of S times H of S. And this G of S times H of S is called the loop transfer function. And basically it's what we have over here. You can see that we have H times G. You should also pay attention to the sign that we have here at the denominator, 1 plus minus. And if you look at the original sign that we have here, you see that it is in the form of minus plus. So then we should remember that if in our feedback, I will just write it again here, assuming that we have G and H. If we have a negative sign here, then in the transfer function for the whole system, we will have G over 1 plus G times H. But on the other hand, if we have plus over here, at the denominator, we will have 1 minus G of S times H of S. Alright, but you may now wondering how this transfer function for the feedback configuration is obtained. In the next slide, we can see how it is done indeed. So if we call the signal here at the input of G of S, the block, as the error or ES, error signal, we can see that now C of S is equal to G times E. But on the other hand, E itself is equal to R. As you can see here, E is the output from the summing point, so E is equal to R minus or plus the output of the block with the h of s as the transfer function, which will be equal to h of s times c of s, because c is the input to the block on the feedback pass. Therefore, if we replace e in the first in the relation that we have between c and e, we will get c of s equal to g times r minus plus h times c. And then if we take all terms with c to one side, we will have c of s times 1 plus minus h times g equal to g times r. Just pay attention that over here we had minus plus, but as it traveled to the left side, it became plus minus. And now we can say that c of s over r of s, which is basically the transfer function that we have for the whole feedback loop, will be equal to g over 1 plus minus h times g. Or in other words, c will be equal to g over 1 plus minus h times g times r of s. It's particularly important, again, to keep in mind the sign convention that we have here. If you have a negative sign in the feedback pass, we will have plus sign in the denominator and vice versa. So in this way, you can combine the blocks which are connected to each other in the form of a feedback loop, and then obtain the transfer function for the whole system.